share.
YouTube.
And now, yes, there we go. I have a background in the development of haptics. Haptics is force feedback, so that's my link with this project. And I would like to tell you a little bit about how we developed a haptic simulator, and in this case, for dental training. There are some similarities, I think, between the project that we did and the project that we are working on now. So I want to tell you briefly in this next half hour about how what challenges we came across and how we dealt with it. So first, this is the product that we're talking about. It is the Simodont Dental Trainer, and I would like to show a little movie to see what it is all about. All right. This is the system that we developed. We started in 2006. And we launched it in 2010 at ACTA, that's the dentistry school in Amsterdam. And what you see here is a handpiece that is held by the student. The student holds the drill and gets force feedback as he drills into a virtual tooth. That is very important to get the force feedback to make proper training, because tooth may seem hard, but if you drill a little bit, you go deep, way too deep. So you need to have the feeling in your fingers. You need to be able to select the tools to make a proper training, log in as a student. Hey, I'm Jos and I want to practice this and this and that. It has to have proper visuals. It had to be integrated in the courseware. Yeah, that was the development, not of just haptics, but of the whole simulator. So this is what I want to tell you about. How did we get to this simulator? You see motors, force sensors, but there's way more to the development of a simulator. Okay, and now let's see if I can go.
Share and then,
yeah. And then I go back to sharing the PowerPoint slide. Yeah. All right. Now at controlling, I'll spare you the movie, but because I have something here. I worked at Moog together with Piet Lammertsen. Maybe you have met Piet Lammertsen already. And there we developed these systems. Force feedback, you see a little motor, and this linkage is on here. And this is a virtual spring. And there's a model with a spring stiff.
Unshare, dan zien we jou in het groot.
Ah, unshare. It is.
Dit gaan kijken. Sorry.
There I don't see the. Here I don't see the power of the Teams. Yeah. Okay. Yes. Okay. Now you see. Okay. Here you see below the table you see a control loading motor actuator with a force sensor and a gearbox, and it runs a model of a virtual spring. So if I let go, it goes back to the middle. There are virtual end stops there, and we can change parameters. This is where we came from when we started in 2006. We were pretty good at developing these systems for flight simulation, and now we want to apply that technique into control loading, into a dental simulator. Sorry. So the question is how? Oh, there we go back. How did we do that? How did we get from the 2006 to 2010 with the launch of the Simodont? The first prototype, yes, it is a prototype, but it's very, very simple. It is this simple mock-up. You see a glass plate on top. That is where I had envisioned that the dentist would see their screen, and they would sit on the left side, and you see a sort of a mask like which is the shape of a hat, and we wanted to see like, okay, where do you sit behind the simulator? There was no such simulator, so we had to ask people, what is it, what do you have in mind, what do you think about? So this was the simple mock-up to see what are we talking about, are we on the same page? And this revealed one of the hidden requirements, because many requirements are hidden. Customers won't tell you what's really important. And they told us that ergonomics is important, posture. Dentists have to sit up straight, and this provoked dentists to bend over, which is not good for your back. So as simple and as stupid as it may seem, it taught us something. Now, then we went into the haptics. We had a simple system with 3 motors. The image was on a separate screen, so there was no collocation of the image yet. It was very, very basic. No rotations included, no 3D whatsoever. But the haptics, they were just the thing that we were good at, and we were asked for that because of the haptics. So we said, what do you feel about this? How does this feel? And the first thing what they said when they felt it, where's the sound? Yeah, okay, fine, but sound will come later, but what do you feel about the haptics? Yeah, I miss the sound. So okay, the sound is important. The sound is apparently a cue. The pitch of the burr drops when you push too hard, and so they pay attention to the sound of the drill. So apparently, force feedback, the sensing, also comes from sound. It makes sense if you think about it, because if you push too hard, then the RPM drops, and the dentist used that cue in combination with the real force feedback. So we had to develop the sound. I will not go into detail about that, but that was a development on its own. Apparently that was, in that stage, more important to convince the dentist of the concept of the simulator. So back to the ergonomics that we discovered. So we had this little box, and how should we then put everything together? Now, you may recognize Pete in his younger years, and we had a setup which consisted of flexible beams, so we were looking for the optimal posture. How could we make sure that you have the picture on the right place and the haptics in the right place? And this is in detail how it looks like. We had a rear projection. You would look at a mirror, and the haptics is below here. Also, the first image, no 3D. It was a pretty coarse resolution. Now it's way more better, and that's, you can see how fast the development has been in visuals. But 0.1 resolution is really too small for a dental simulator, but good enough for your first prototype. So later we developed the stereo and the realistic graphics, but that was good enough at that time. So then next, what was important? Now it was important to get it into a whole system, and we call it the IKEA model because it was basically made of wooden planks. It was the same box, but then in a sort of frame glued together, just to have an impression of what the simulator would look like. The courseware PC, of course, yeah, why not make a table with your laptop on it? And so this was our first simulator that contained the sound, the graphics were, actually this is a fake picture, but that's also good to fake every now and then if you can get away with it. But we had a very basic model, and that gave us an impression of how the simulator would look like in the end. It gave the customer an impression of how the simulator would look like. And they said, yeah, this is the right direction. That was a year later. Then we could go into details with the motors and the haptics. Now we used 3 servo motors, no gearbox, just some lever gearing, and it's not that stiff, but it was good enough. I'll come to that later. We developed a special force sensor in here, and we had a gimbal such that the drill can rotate. That was all needed to have proper force feedback on the tip of the drill. Now, of course, we had to have teeth, and that was one of the things why we were asked in the first place, because if the students normally would drill on plastic teeth, and plastic is very uniform. It's plastic all the way. That's not as hard as a real tooth, and it's inside and outside is equally soft. But the real tooth has more information, so we had to make a proper model based on CT scans with different stiffnesses or hardnesses of the tooth. Develop the model in that as well. So that was a true challenge to get that right. And then to get that working with the haptics, we discovered like what is really important. Now, and if you're drilling, then when you're not in contact with something, you should feel no friction at all. That was important. It had to feel very lightweight because you don't want to have a drill in the air that has a lot of friction. That was important in our application. Think for the teams 5 and 13, what is important in your application? What is the important field there? We discovered that although a drill is like a cylinder, a point contact was good enough. So we don't give force feedback on the rotation, good enough. And the first contact of the drill hitting the tooth gives a really hard tick, as you can imagine if you tick on your own teeth. So what was important is that we give the illusion of a hard surface. The stiffness of the system was not that stiff, not as stiff as a real tooth, but we were able to give the very first ting of the haptics that gave the illusion of a very stiff surface. So the dentist would feel, oh, this feels really, really stiff, but it was not stiff at all, but it gave the illusion. And there was even some study on that. It was called rate hardness. If you want to know the haptics about it, the details about it, go read it. But it is important to think like, how can you fool the dentist that he has the illusion that he's hitting a tooth? Because we didn't require that stiffness at all. There's also something to take in mind when you develop flight simulation for controlling for a flight simulator. What is important and what are the cues that he or she really needs? Important thing to research. Now, 2010, we had it. We had the whole system. We installed 40 systems with haptic feedback. We had the models of the tooth and the gum around it. That's also important. It was 3D with a stereo projection on the display. And we had courseware in that. Come back to that later. Also, the foot pedal is important. It really looked like a simulator, and this is how they were installed in 2010. And they have been running like that up until now. I just heard that they are replacing the first batch installed in 2010 this year. That means that the first version of this system has been running for 10 years, and that is well, that's pretty long time for a first launch. Courseware integration. Once we got the systems installed, then we could work on the courseware integration. And what do I mean by that? The procedures. So it's okay if you can drill on a single tooth, but you want to train special procedures. What is it that a dentist has to learn? It is about crown and bridge work, to place a crown on tooth. Cardiology. They want to have practice blocks. All these things that are normal procedures that dentists have to train, they wanted to be in the simulator. And of course, they wanted more and more, such that the simulon would be a greater part of the curriculum. And that's also when you think of flight simulations, which procedures are you going to take first, and can you expand later on? And then the simulator gets more and more value if you have more and more procedures. On the other side, it had to be integrated in the curriculum, meaning that there's more to drilling to become a dentist. There has to be grading, there has to be scenarios of the waiting room that a patient comes in and has complaints. You have to write a plan, like how am I going to treat that patient? That's not just the haptics, not just the drilling, but those are things that we integrated slowly into the simulator, such that it becomes a part of the school. And you also want to do objective assessment, like, okay, you scored an 8 on this procedure, or you scored a 4 on this procedure. All those things can be integrated in the simulator, but it requires work, but that adds the value. Now, to come to the end of it, the summary is that when we started developing the simodont, we started off with haptics because that's what we knew. Remember the control loading showed in the beginning. But there was so much more that was important, and all these blocks, I just picked 6 of them, have to be in place, or else the simulator would just simply fail. We had to have haptics, and we got away with the illusion of the hard surface to keep the haptics fairly simple. Without visuals, there was no proper training model. The sound apparently was inevitable. There had to be a realistic model in there to make sure that it felt good, and the whole system had to be ergonomically suitable, the right posture. It had to fit in the classroom. The procedures had to be added to the courseware, and it had to be integrated in the school. And all these things together were needed, and every piece of the puzzle was needed to make the Simulon valuable. And so I want to emphasize, like, it's good that we are developing control loading for the flight simulator, but there is we should also take in mind the other aspects. I'm not saying that these 6 aspects are equally important to the flight simulator. There may be other aspects too, so get them in place. And once you think like the control loading is good enough, think, okay, what's the next thing that needs to be developed to make the customer happy, such that he has in the end, a proper simulator. So this is my talk about the development of the Simulon as we developed it at MOOC between 2006 and 2010. If there are questions on this or on the control loading system here, I'll be happy to answer them. All right, let me see if I can see the teams. Is there chat? Ja.
Ik zie nog steeds dat je presentatie gedeeld is. Kun je hem unshare? Even op dat klikje.
Ja, unshare. Ja. Oké.
En dan zouden we geen vragen.
I see no questions, meaning that everything was clear. A question from Mace. Did you underestimate one of the tasks? Yeah, actually all of them, and that's how it goes. I think it's the sound. We didn't know at first it was that important, and in hindsight it's pretty obvious, but we had to work on that. And one of the things that after, but I didn't tell you, that after 2010 became the real challenge to make the Simulon a bigger success is the procedures, the development of the procedures that determined the success, because we only first could do 4 hours of training in a year, and that is then a Simulon is very expensive for a school if you only do 4 hours of training. So to develop those procedures properly, to think like how can we make more training time on the simulator, that was something that we didn't fully understand up front, and also because it was fairly new and the professors didn't know what to expect. They came with new questions later and later. That was also challenging. So, but I think the courseware aspect was the main underestimation of it. And so, yeah, as that would reflect on your assignment, it's nice if you can fly around, can do a couple of procedures, but think a little bit ahead. What does flight training mean? And think that if a flight training consists of 100 hours and you only provide 2 hours of training on the simulator, then there's probably not a viable business case for your simulator. So how can you increase the numbers of hours, or in a smart way, reduce the total number of training hours? What is the added value commercially of your simulator that you are developing? Are there more questions? Yeah, okay. Then I thank you for your attention, and Arnold is going to close down the session. You want the mic?
Yes, thank you. Well, thank you very much
Jos Meuleman. I think that was really an awesome presentation. I saw some familiar parts in there. And a couple of times you mentioned the word customer in this story. So who was the customer actually?
The customer. Am I still on the microphone?
No. Oh, sorry. Yes. Yeah, so I'm going to repeat what Jos is going to say.
Okay. The customer was ACTA, the dental school in Amsterdam.
Yeah. So Jos just said that ACTA was the customer, a dental school in Amsterdam. Yes. Do you know who is actively working with ACTA? In Holland. In Holland. Yes. So, in some way, in Holland was actually your customer. Yeah. So I think that's a really nice way to conclude this presentation from Jos today. And I want to thank everyone. I see about 60 people kept online during the presentation, and I think some had to go for another meeting, so they dropped out. But there's still 45 people online. So thanks for staying online. Any feedback, put it on the chat or send me an email. And I want to wish everyone good luck today with their project day. And yeah, stay safe and see you soon. So bye. Thanks.
Woo!